1,000 feet of length and over 40,000 tons of steel characterize the massive ships that complete their final voyage every year. Hundreds of these floating giants bypass equipped ports. Captains steer the vessels straight onto the muddy beaches of South Asia. It seems like a reckless maritime disaster, but in reality, this grounding is calculated. Why is such a crude method used instead of dry docks? Standard facilities are often too expensive for such tonnage. Tides allow the ships to settle firmly on the flats for access. Thousands of workers stand waiting on the shore to dismantle the structure by hand. This labor replaces automated machinery. One can notice the sparks from cutting torches heating metal to 5,400 degrees Fahrenheit. Laborers work for wages of less than $4 a day, but the process is only gaining momentum. They cut apart every steel plate, compartment, and pipeline. More than 90% of the materials return to the production cycle. However, the price is a hazardous working environment. The floating cities vanish as if they never existed. The steel is thus prepared for a new life. 100,000 vessels currently make up the colossal scale of the global commercial fleet. One can notice the sheer density of maritime traffic when viewing the industry as a whole. But this number is constantly in flux. Shipyards launch around 2,700 new ships annually to replace the aging generation. Simultaneously, 400 to 500 older vessels are permanently retired from service each year. Why must these massive steel structures be retired after such a specific period? The standard service life typically lasts 25 to 30 years before critical changes occur. After this point, maintenance costs rise rapidly, making continued operation financially unsustainable. It is visible how salt water gradually eats away at the steel hull over decades of service. At first glance, the ship looks solid, but in reality, the cargo holds and engines can no longer maintain the original level of safety. One can notice how rust penetrates the structural beams, and this is not the only threat to their longevity. Global emissions standards now require ships to drastically reduce sulfur content in their fuel. Consequently, many older vessels become legally obsolete as they cannot adapt to these new environmental regulations. Beyond gradual wear, sudden catastrophes like collisions, groundings, or severe fires force ships out of service immediately. One can observe the severe mechanical failures that render the engines useless. When the calculated repair costs finally exceed the vessel's operational value, dismantling becomes the only option left. The ship is then ready for the final stage of its life cycle. 70% of global shipbreaking activity concentrates in just 3 specific locations. A crucial question immediately emerges regarding the fate of these massive vessels after their final voyage. Where do they go? One might imagine they are dismantled at sea in complex salvage operations involving cranes, robots, and precise structural simulations. But in reality, the process is far more terrestrial, leading straight to the beaches of South Asia. They are towed directly onto land. Why does the industry choose these specific coastlines? Labor is accessible, the beaches are wide, and the local demand for scrap steel remains enormous. The final destination for a retired ship is very likely to be one of the 3 most famous yards in the world: Alang in India, Chittagong in Bangladesh, or Gadani in Pakistan. In Alang, captains drive hundreds of ships directly onto a shoreline stretching about 6 miles every year. One can notice how the vessels form a massive open-air dismantling assembly line as they grind to a halt on the sand. But this is just the beginning. Chittagong utilizes a distinct beaching method, forcing ships onto muddy shores using the full power of high tides to push the weight inland. It gets more complex further on, but Gadani was once the fastest center in the world, though that speed came with significant risks. Therefore, despite differences in scale and technique, all 3 locations share the same industrial role. Workers strip apart tens of thousands of tons of steel, removing it plate by heavy plate. At first glance, the method looks chaotic, but in reality, it is a critical mechanism for feeding metal back into the global economy. The steel is now ready for repurposing in new markets, 3 to 6 million United States dollars. This is the potential revenue generated by a standard cargo ship during the valuation stage. Buyers, typically scrap steel traders or specialized shipbreaking companies, assess the vessel based on two critical factors. Why is the assessment so rigorously tied to the market? At first glance, the ship seems like a simple mass of metal, but in reality, the profit margin is tight. The final price depends on the calculated volume of recoverable steel weighed against the current market price of scrap. Cruise ships command an even higher valuation due to their complex composition. These vessels contain significantly larger quantities of non-ferrous metals and stainless steel. One can notice the additional value in the expensive interior equipment that remains on board. But this is just the beginning of the material separation process. The dismantling operation generally falls into two categories: breaking the hull for scrap and carefully dismantling sections for component reuse. Most of the steel, copper, and aluminum are recovered for melting. It is visible how electrical cables, propellers, and drive shafts are extracted systematically. Machinery systems are removed with care to ensure they remain functional. It gets more complex further on. Highly valuable components like main engines and hydraulic pumps are removed for strict inspection. Navigation equipment and generators are resold to smaller vessels or distributed to local markets. Thus, before the ship is officially cut into sections, it completes its final economic role as a source of raw materials for different industries. One final journey awaits the ship after the completion of the sale paperwork and the mandatory final inspection. Since the vessel is no longer capable of moving on its own, a team of tugboats takes on the heavy task of towing it towards the scrapping yard. Why is the critical moment of beaching strictly limited to the few hours of high tide? At first glance, the ocean seems deep enough at any time to accommodate the vessel. But the rising seawater lifts the massive hull, creating enough depth for the tugboats to control the direction and thrust. This allows the ship to slide deep onto the sandy beach with calculated momentum. It seems like a simple maneuver to let the ship slide, but in reality, if the calculations are wrong, the vessel can become stuck offshore or drift off course. Such an error creates major difficulties for the entire operation. When everything goes according to plan, the ship moves onto the beach under its own momentum and comes to rest there. As the tide recedes, the hull settles firmly into the shoreline. One can notice how the water retreats to expose the enormous underside that has remained hidden beneath the surface for decades. This marks the physical transition from a vehicle of transportation to a massive material waiting to be dismantled. In the months that follow, hundreds of workers will move through every steel compartment, dissecting the ship from the inside out. The first stage focuses on completely emptying the ship's compartments. Workers begin dismantling the interior, removing doors, tables, chairs, lights, and stainless steel railings. Decorative panels, electrical wiring, and ventilation systems are stripped away manually. But this is just the beginning. Each item is inspected to determine whether it can be reused or resold. For cruise ships, this work is far more complex because areas such as theaters, cinemas, gyms, swimming pools, and bars must all be processed. Hundreds of cabins must be stripped one by one. Many valuable components, such as industrial kitchens, sound systems, and air conditioning units, are removed intact and sold on the market. Once the interior layers are removed, the environmental handling team takes over. They pump out residual oil from the tanks and treat sludge, wastewater, and any chemicals remaining in pipelines and technical tanks. This is an extremely critical step. Even a small amount of flammable gas or uncollected oil can turn the flame of a cutting torch into an ignition source. After everything is cleaned, the ship is left with only an empty steel framework. It gets more complex further on. The ready framework awaits the heaviest stage, which involves cutting the hull. Workers erect scaffolding and mark the cutting lines with precision to prepare for the dismantling of the structure. It is visible how oxyacetylene cutting torches, burning hotter than 3,000 degrees Celsius, pierce steel plates nearly 3 centimeters thick. Each completed cut separates a steel section weighing several tons. These sections are carefully rigged with cables before being dropped onto the sand by gravity. The sound of steel hitting the ground always echoes across the yard, signaling that part of the ship's body has been severed. Tractors then drag these large sections deeper into the yard to be cut into smaller pieces. 3 teams of workers, steel cutters, transport crews, and cable recovery teams work continuously to recover as much material as possible. Depending on the size of the ship, this entire stage can last from several months to more than a year. The process moves forward without haste. 12 to 16 hours a day is the standard shift duration for shipbreaking workers. They earn only about 3 to 4 United States dollars for this grueling labor. Why is the official accident count limited to nearly 2,000 since the late 1960s? Many migrant workers are not officially documented. This implies the actual number of incidents is likely much higher. One can notice how laborers navigate the superstructure with minimal gear. But this is just the beginning. The dismantling operation extends from several months to more than a year of continuous work. At first glance, the process may sound sequential, but in reality, the work is extremely dangerous. Workers face the risk of falling steel and slipping from heights. It is visible how they balance on the metal structures without advanced safety gear. Because hazardous residues remain, explosions caused by residual oil are a persistent threat. Inhaling asbestos dust poses a silent danger, as this substance can cause permanent lung damage. Dust slowly settles in the air where protective equipment is often unavailable. Access to medical care is limited at many yards, and this is not the limit. The industry relies more on human labor than on machinery, keeping the risk of accidents ever present. International organizations have made efforts to improve conditions, but change has been slow. Outside the yards, many workers live in makeshift housing, lacking clean water and basic sanitation. One can observe the challenging environment extending beyond the work site. Consequently, the physically demanding and unstable nature of the work limits access to education and insurance. This forces many to remain tied to a highly dangerous occupation for years. The dismantling industry continues to operate on this difficult foundation. 40,000 tons of high-quality steel can be extracted from a single large cruise ship. This enormous economic potential has allowed the shipbreaking industry to function as a vital occupation for more than half a century. A medium-sized cargo ship typically supplies 10,000 to 25,000 tons of reusable metal. As torches slice through the hull piece by piece, every steel plate, every pipe section, and every structural frame transforms into a valuable resource. All of this steel travels to furnaces to be reborn immediately. Why is the demand for recycled ship steel so consistently high? It might seem that producing fresh metal is standard, but recycling saves up to 70% of the energy compared to producing steel from raw ore, while simultaneously reducing carbon dioxide emissions. The melt turns into billets, rebar, and plates for construction, bridges, and roads. At first glance, the massive steel hull seems to be the only asset, but in reality, non-ferrous metals are recovered at high rates. One can notice how workers extract copper from electrical wiring and aluminum from railings. Brass is reclaimed from propellers, and stainless steel from industrial kitchens. These materials possess long service lives, and their reuse helps reduce pressure on natural resources. But the process does not stop at raw metals. Intact mechanical units are carefully inspected for resale. Compressors, generators, pumps, and navigation systems are sent to local markets. From a vessel that appears to have lost all value, the industry generates millions of United States dollars. The equipment is thus prepared to continue its journey in new projects. Dozens of hazardous substances hide inside the hull of a single decommissioned vessel. Shipbreaking is often described as a victory for the circular economy, where steel is recovered and global emissions are reduced. Why does this process often turn into an environmental disaster? The recycling goal seems ideal, but without strict control, the environment dies elsewhere, and the price is paid in soil, water, air, and human lives. Dangerous materials lurk behind every corroded steel panel. Workers encounter asbestos in piping insulation and lead-based paint coating the hull. One can notice how residual oil pools in tanks alongside biological waste from cruise ship sanitation systems. But this is just the beginning of the threat, because without containment, toxins seep into the ground or flow into the sea. This causes damage that lasts for years. At first glance, the beaching method looks efficient due to cost. But in reality, it operates on open sand without proper waste treatment. It is visible how the runoff stains the coast. Therefore, severe contamination persists in the area for decades. Measurements show that concentrations of heavy metals near these yards exceed permitted levels. Fish populations decline sharply, and local residents face serious health problems. The process concludes, leaving a heavy mark. 10 to 15 years is the duration required to completely dismantle a single nuclear submarine. This specific class of vessel cannot simply be driven onto a sandy beach for rapid cutting. Inside the hull lie active reactors, spent fuel rods, and radioactive cooling systems that demand absolute isolation. One can notice the thick steel shielding the core. Consequently, only 3 nations, the United States, Russia, and the United Kingdom, possess the technical capability to handle such hazardous decommissioning. But this is just the beginning. Why is the process of breaking down these vessels so strictly limited compared to standard commercial ships? The engineering complexity provides only a partial explanation. The primary cause lies in the extreme danger of contamination if the hull is breached improperly. One can notice how specialized teams work in sealed dry docks rather than on open shores. At first glance, dismantling seems like destruction, but in reality, it is a surgical operation to remove nuclear components. It gets more complex further on. Global authorities are now implementing rigid frameworks to manage these environmental risks. The Hong Kong Convention of 2009 adopted strict standards for safe and environmentally sound recycling, though it formally enters into force only in 2025. Simultaneously, the European Union strictly mandates that ships flying the EU flag must be processed exclusively at approved facilities. One can notice how these legal measures slowly shift the industry toward verified yards. The era of uncontrolled scrapping transitions into a phase of regulated precision. Hundreds of workers labor day and night on the extensive ship-breaking beaches stretching across the coast of South Asia. Every vessel docking here bears the physical traces of years spent crossing waves and transporting goods to distant lands. These ships have carried people to places they had never set foot before, accumulating wear on their massive hulls. The journey on water ends, but the material remains. But this is just the beginning. Why must the operational life of these steel giants end at these specific approved facilities? The ship does not simply disappear into oblivion. It undergoes a complete dismantling to return valuable materials to the world. Workers manually cut apart the massive steel plates, often operating under intense conditions to separate the structure piece by piece. One can notice how gas torches slice through the thick plating, dividing the vessel into recyclable segments. At first glance, this looks like a graveyard for machines, but in reality, it is a vital link in the global economy. This life cycle is filled with risk and controversy, yet it provides the essential raw material for future bridges, factories, and industrial zones. The transformation is only gaining momentum. Sometimes the reclaimed metal is even used in the construction of a new ship, continuing the journey in a more durable and silent form.